Hi everyone, in today's lesson we're going to talk about implicit differentiation. Up until now, all we've learned is explicit differentiation. An explicit function is a function in which the variable is defined only in terms of the other variable. So all you've seen is when I've solved for y equals, like these three examples here, and when we just take the derivative. But an implicit function is a function in which the variable is not defined only in terms of another variable. So you see here it's x squared plus y squared, and the y squared is here, and there's another y here, and so on and so on. There's basically y's all over the place. So if you take a look even at this function here, wouldn't it seem almost nearly impossible to get y by itself? Even same thing here, you'd have to take probably a square root of y at some point, bring the y's over. I'm not entirely sure that these two, or even this one, it would be easy to solve for y equals. So when do I use implicit differentiation is when it's difficult to solve for y equals. We're going to use explicit differentiation when the equation is already solved for y. Okay, and the application to this is that after we find the derivative, we can then find the equation of the tangent and normal lines like we've been doing so far. So let's look at an example where we could use explicit or implicit differentiation. So if we look at this first example, it's already solved for y equals. So we already know how to do this. We're going to take the derivative using the power rule. Okay, so dy dx will be the derivative of y. So dy dx equals 2x plus 2, right? That's the derivative. Now, we can take this same equation. Now, isn't this the same exact thing as this equation? All I did was just move over the x squared and the 2x term and brought it to one side. So now this looks like it's a difficult problem to solve, but we could use implicit differentiation. So what that means is we're just going to take the derivative of each piece separately. So the derivative of y we know is dy dx. The derivative of 2x, or excuse me, x squared, is 2x. And the derivative of negative 2x is minus 2. And the derivative of any constant of negative 3 is 0. And all we have to do is now just solve the equation for dy dx. So I could add the 2x minus 2 to both sides, or plus 2 to both sides. So add 2x, add 2. And these will all cancel. And I'll have dy dx equals 2x plus 2. So in this case, we used implicit, and in this case, we used explicit to get the same result. So now let's focus our attention on implicit differentiation. So I'm going to give you hard problems where it's not already solved for y. So look at the example. Example number 1. Find the derivative using implicit differentiation. The y is not by itself, so we're going to use implicit. So we're going to take the derivative of x squared, and we're going to get 2x. And we're going to take the derivative of y squared, which gives me 2y. But because we've taken the derivative of y, we have to apply the chain rule here, which says to write dy dx right next to it, equals 0. So the key here was that because we took the derivative of a y function, we have to write dy dx. We never had to do that for the x's when we took the derivative with x, but when we took the derivative of y, we got dy dx. Technically, the derivative of y is just 1. And we never really write 1 times dy dx. Same thing here, the derivative of y was 1 times dy dx. Okay, so same thing here, when we take the derivative of y squared, it's 2y times dy dx. We're telling us that we're taking the derivative of y with respect to x. And then now we're just going to solve this equation here for dy dx. So I can bring the 2x over by subtracting it. So minus 2x. So I have 2y times dy dx equals negative 2x. And then to get dy dx by itself, I'm just going to divide by 2y. So divide by 2y. So dy dx is equal to negative x over y. All I did was just cross out those 2's. So this is my derivative with respect to x. Okay, example number 2. Same concept as example number 1. We're going to take the derivative of each piece. So the derivative of x squared is 2x. The derivative of y squared is 2y times dy dx. Remember, every time we're taking the derivative of y, we have to attach a dy dx. Derivative of negative 4x is negative 4. Derivative of 5y is 5 dy dx again, because we took the derivative of y, and then minus 0, the derivative of a constant, is 0. So the idea when you have more than one dy dx, like we have here and here, is we're going to keep these terms on one side and move all the other terms to the other. So realistically, I could subtract 2x, add 4, and I don't need to do anything with the 0, but so minus 2x, and then plus 4. So these two terms we're going to leave here. So we have 2y times dy dx plus 5 times dy dx equals negative 2x plus 4. Now, the question is, well, how do I get just one dy dx? And the trick here is that we're actually going to factor. We're going to take out a greatest common factor of dy dx. So dy dx is the GCF. We pull it out on the outside, followed by an open parenthesis. So when I divide 2y by 2y dy dx by dy dx, I get this term. So it's 2y. And then when I divide this term by this term, I get 5. So 2y plus 5 equals my negative 2x plus 4. So then the only thing left to do is, since this dy dx is attached to this by multiplication, we just divide both sides by the 2y plus 5. Okay, so then the final answer for dy dx is dy dx equals negative 2x plus 4 all over 2y plus 5. This is my final answer. All right, let's move on to the next page and see what other problems I have for you. Okay, so next we're going to take the derivative of number 3. So again, each piece. So the derivative of sine y is nothing other than cosine of y. But remember, we took the derivative of a y function, so we need a dy dx. Next, we're going to take the derivative of the middle term. And the middle term here, x squared y to the third, is actually a product rule, where we'll call the x squared the high function and the y to the third the low function. So remember, the formula for the product rule is low, so the low, d high, derivative of x squared is 2x, plus high, d low. Now the derivative of y to the third is 3y squared, but since we took a derivative of a y, we need to write dy dx. And then the next term is the derivative of negative cos. Well, the derivative of regular cos is negative sine. So a negative and a negative make a positive. And the derivative of of 2y is positive 2. But again, we need another dy dx because we're taking the derivative of a y value. Okay, So I know this looks a little bit difficult, but we're going to just keep all of the terms that have dy dx on one side, and we're going to move these terms to the other side. So I kind of think that it's a little bit easier if you could do this in your head rather than writing it out. So what I want to do is I want to leave this term and this term on the left side, and I want to bring this term over. So if I rewrite that, it's cos y times dy dx plus x squared 3y squared dy dx. And then if I'm bringing this over, it needs to be a minus. So it's minus 2 dy dx. And then equals, and I want to bring all of these terms, this one and this one, to the right side. So this term to the right and this term to the right. So it's going to be a negative y to the third times 2x and a negative sign of x. Okay, so then now we can focus on this left side where I'm going to take out a factor of dy dx. So dy dx goes on the outside followed by an open parenthesis. And when we do the division of this term by this, we get cos y. And then when we do the division of dy dx and this term by dy dx, we get this, which I'm just going to rewrite a little bit nicer as 3x squared y squared. And last but not least, when I divide this into this, I get a minus 2. And that is equal to all of this. Negative, I'm going to rewrite this nicer, 2xy to the third minus sine x. And then last but not least, to get dy dx by itself, we're just going to, since this is attached by multiplication, we're just going to divide out this whole thing. And just for purposes of space here, I'm just going to rewrite it without showing the division. So dy dx is equal to negative 2xy to the third minus sine x all over cos y plus 3x squared y squared minus 2. And that is my derivative. Okay, last but not least, I could ask you to find the equation of a tangent line at a given point. Now, this is something that should be familiar to you, but now the problem is not written in y equals. So we're going to use implicit differentiation. So I'd actually like you to try that on your own and ignore this point right now and just do the implicit differentiation, hit pause, and then hit resume when you're ready. Try not to cheat. Okay, here is your work, or the work that you should have for the implicit differentiation. Alright, take a minute if you need to pause the video to fix your work, but now I'm going to move on to finding the equation of the tangent line. So the derivative gives us the slope, remember? Derivative gives us the slope of the tangent line at any given point, right? Remember that part? So if this gives us the slope of the tangent line at any given point, well, we have the point. The point is 2, 1. So if I want to find the slope at that point, we're just going to plug in now, in this case, x and y. So the slope at 2, 1. So we're going to plug into this equation x and y. So negative 2, x is 2, y is 1 squared over 2, x is 2 squared, y is 1 minus 3. So this will give me the slope. So all I did was plugged in x and y here in x and y, 2 and 1, into this whole equation. And then we just simplify the top and simplify the bottom. And that is our slope of the tangent line. So let's see if we could do that real quick. 2 and 2 is 4, so negative 4 on the top. And the bottom is, this is what? 4 times 2 is 8, minus 3 is 5. So negative 4 over 5 is our m. That is our slope. So remember, the equation of a line is y minus y1 equals mx minus x1. So remember the point, that's always x1, y1. So it's going to be y minus 1 equals negative 4/5 x minus 2. This is my equation of tangent line. And that is it. Alright, I know I went through a lot today, so please make sure you jot down any questions that you have and ask me in class tomorrow. Alright, have a great night.